Dear students, discussion of the solution from linear motion, tutorial 1, the star questions. Question number 8. Two identical objects, X and Y, fall from rest from different heights to the ground and air resistance is negligible. If object Y takes twice as long as object X to reach the ground, what is the ratio of the heights from which X and Y fell? So you need to picture the idea, the situation. So you have identical object X and Y. So I can say, okay, this is X and this is Y. And it is mentioned that if object Y takes twice as long as object X to reach the ground, that obviously explains the object Y is dropping greater height compared to the object X. Because, so this is the Sx and this probably the height Sy. And the time taken here is Tx and the time taken for Y is Ty. But understood that Y takes twice as long as object X. That means I can say my Ty is equivalent to 2 times of Tx. And both objects fall from rest. That means my Ux and my Uy should be equivalent to 0. Okay, so in meter per second. And what are falling under the influence of acceleration due to the gravity? So therefore the Ax equals to Ay. That should be equivalent to the negative G. So this is what the information that you can gather from the question. And next, we understand that obviously the height Sx and Sy is not the same. So Sx is not equivalent to Sy. Okay, so this is the information. So now, if I were to find the height dropped by the object X for a time of Tx. So what is the formula I can think of? The formula which relates the distance, the time, and the acceleration due to the gravity. So I can have an equation Sx equals to Ux, but we understand the initial velocity for both is 0, multiply by the time that is taken Tx plus half negative G Tx squared. So this is for my object X. Okay, so this is for X, equation 1. Then for object Y, I have Sy equals to Uyty plus half minus T Ty squared, equation 2. So obviously we understand that the Sy and Sx, because the displacement is downward, it will have a negative. And you can see on your right hand side also there is a negative. So eventually the negative will cancel off. Okay, so you don't need to worry about negative much. Okay, now how to the question, what is the question? The question, what is the ratio of the height of Sx to Sy? So Sx, so we want to find the ratio of Sx to Sy. We know the initial speed as Ux and Uy are 0. So this is basically will not involve. That's 0. then you are just going to take your half minus g t x squared over half minus g t y squared. Half minus g all cancel. What is remaining is tx squared divided by ty squared. But we know ty is equivalent to 2 times of tx. So you can substitute either tx you can substitute with ti, or ty you substitute with tx. Then you simplify, you will get your answer. Okay, so that's how you solve the question 8. So you solve it. Next, question 9. In a relay race, okay, in a relay race, runner A is carrying a baton. Baton. Okay, so runner A carrying a baton and has a constant speed of 3.00 meter per second. Important information. When E is 25.0 meter behind the starting line, runner B starts from rest and accelerates at 0.100 meter square. How long afterwards will A catch up B to pass the baton to B? Those who athlete relay runners, you may have some idea about this. So I can take a race track. So this is just say person A running with a speed as mentioned, constant speed of 3 meter per second. Don't worry about a 3.00. Okay, so just put it rounded up. Then the person B is at a position, okay, here, and is starting with the initial speed of 0. So for A, the initial speed is 3. For B, the initial speed is 0. But what is it? From rest and accelerates. So there is an acceleration for B, which is equivalent to 0.1 ms minus 2. Okay, fine. And we know that the distance between A and B, it is given as when E is 25 meter behind the starting line. This is the initial starting line, so E is behind 25 meter. Okay, so you need to understand all of this in the question. Okay, so how long afterwards will A catch up with B to pass the baton to B? Meaning after this line, both SB and SA, the distance going to be traveled by both person A and B is obviously going to be the same. You need to understand that. If you don't understand that, then you're not able to relate. Because then only if the distance traveled by A equivalent to the distance traveled by B, when A travel at constant speed equivalent to the B which is accelerating, then only the baton can be passed at a particular point. So now go back, the same idea. So you have these informations. So you can form an equation to find the distance traveled by A as A. So as A equals to the initial speed is UA times the time plus half acceleration t squared. But we understand that the acceleration for A, this one I'm referring to runner A. For runner A, I understand my UA is equivalent to constant speed. And my acceleration is equivalent to 0. So therefore, my UA is 3 multiplied by the time. So that is my SA, the distance traveled with a constant speed. So 3 times the time. So what about for B? So for B, same thing. SB equals to UB T plus half A B T squared. Okay, so we are going to find how long, okay, how long afterwards. So we are going to find the time. So the time taken for the both person will be the same because they are going to cut each other. So the time involved will be the same. The distance has to be the same. The time will be the same. Then only they can come along. Otherwise cannot. So UV already mentioned initial velocity. Okay, so here the acceleration is 0. Okay, so here the initial velocity is 0, UV. So you must understand my initial velocity UV equals to 0, but there is an acceleration which is 0.1 ms minus 2. So since initial velocity is 0, this whole thing will be 0. So I will just have half times 0.100 t squared, equation 2. But we understand that SA is equivalent to SB, right? Meaning my equation 1 should be equivalent to equation 2. So equation 1 equals to equation 2. That's all. You equate and solve the problem. So you equate equation 1 equals to equation 2. So you get your answer. Okay. That is for question 9. So last question. Question 10. If you understand question 9, it's the same concept. So I'll just give you a bit idea, then you figure it out. At the instant a traffic light turns green, a car that has been waiting at the intersection starts ahead with a constant acceleration. So meaning, so I draw a line. Oops, sorry. So I have a car here. Okay, it starts. So mean it starts from initial velocity 0. Okay, so waiting at intersection starts with the initial. Okay, so ahead with the constant acceleration. Okay, so constant acceleration. Okay, so it has an acceleration of 2.00 meter per second per second. At the same moment, a truck traveling with a constant velocity of 15 meter per second overtakes the and passes the car. So meaning a truck, how the truck will look like. So we just draw a bit bigger lah, truck. Okay. So this truck going to overtake, but then it moves at a constant speed of 15 meter per second. So basically the time, we will start the time from the starting line. So at the starting line, the truck is already moving at constant speed 15, but the car is just accelerating. So definitely at the starting line, the truck will be leading the car. But because the car is accelerating, eventually the car will catch up. Okay, so calculate the time necessary for the car to reach the truck. So the idea is, when the truck is going, definitely is going forward, but because the car is accelerating, eventually it will come and cut. So the time when the car overtakes, the distance traveled by the truck and the distance traveled by the car will be the same. So again, like question number 9. So you will form an equation which representing for the bus, sorry, for the truck. So ST equals to U T the time plus half a t squared. This will be s car u, okay, for the car, time plus half a t squared. So we understand that for the truck, the acceleration is 0. Okay, so the acceleration is 0. But for the car, the acceleration is 2. So like what you did in question 9, you can substitute the information into these two equations. So equation 1 and equation 2. And obviously we understand that the distance travel st is equivalent to sc. Then from that you will be able to solve to find the time, just like what you did. So after that, I think B and C you should be able to solve it. Okay, so that's it for now. Okay, so I will end the session.